good morning, everyone. My name is Charles Phillips. I'm the Technical Training Manager here at Lochinvar. I want to thank you for taking time out of your busy schedules today to join us as we talk a little bit about the EnergyRite pool heater. Joining me in studio this morning is Mr. Jonathan Girardi.
Morning, everyone.
Jonathan will be kind of tag teaming it with me this morning as we kind of go back and forth a little bit talking about the various parts and pieces of the EnergyRite. So hopefully you won't get tired of hearing just one of us speak, so we'll kind of mix it up a little bit between the two of us. I do have a couple of things to go over with you. First is we are recording this session. If you've got someone who couldn't make it this morning and they do want to catch it, we will be posting this on our training website, which is can be found at www.lochinvaru.com. There you will find all of our previous recorded webinars that we've done throughout the year. So if you want to go back, you can catch any of the other ones that we have done. Also, look at any of the other training tools that we have available on that website. The other thing that we've got for you today is if you have questions, and we do invite those questions. If you have a specific question, type those in the Q&A box. That will get them to us, and then we'll be able to answer those online live for you. If for some reason you hit us with something, hey, we can't answer, we will make sure we get back with you with an answer, all right? So, Jonathan, what do you say we jump into this thing?
Let's do it.
All right, cool. So, if I can get the technology to work here. There we go. Our EnergyRite pool heater basically starts in sizes from 150,000 BTUs up to, we'll round it up to 400,000. It's actually 399,000, but it's just easier to say 400. The EnergyRite's actually a fairly old product. It's been around for quite a long time.
This is the third generation, right?
This would be the current third generation, right? The first generation came out in the early, or I should say the early 90s when I first started with the company. Yeah, it's been a while. And it's gone through several revisions as we've gone through the day. Now, the product that we'll be talking about today will be the most current version of the product. Realistically, between the second and the third generation, the primary difference is just the control. As far as the gas train, the burners, basically the look and feel of the units pretty much remains the same between the second and the third generation. It was just basically the controls that was the main difference. So what you learned here today would apply to some of the older products as well. All right. Now let's talk a little bit, let's kind of give you an exploded view of the heater, kind of talk about the assembly, and as we go along, we'll kind of step through the assembly process. But when you look at the exploded view of the unit, it's very similar to a lot of our other horizontal copper products, like our copper fin 2 and our copper fin products. Your burners, multiple burners laid out horizontally, come out through the front. Access to your blower, your controls are done through the front as well as the top. So it's very similar construction to a lot of our other products. The main difference between the EnergyRite and those other products would be with how the heat exchanger goes into the unit. The heat exchanger for the EnergyRite goes down from the top side, whereas with, say, your copper fin 2, it slides in and out through the front. So for this assembly purposes, if for some reason you ever had to remove the heat exchanger from an EnergyRite, it's going to be a little bit more involved. It's not necessarily hard. You just got to remove a couple extra panels. So you got a few more screws to take out at that point. So still a fairly easy proposition if you need to remove the heat exchanger from the unit itself.
It's still, when you're servicing the unit, it's still probably a good idea to take the top off of that heat exchanger as well, the top sheet metal panel as well, so you can have a little bit better access too, right?
You could, if you need to really get into it and clean it, yeah, you would want to take that off. So as far as the look of the unit itself, basically just looking at it from the front side, you get your upper chamber access and your lower chamber access. One of the things that they did with the second generation is you can kind of see that split in the middle there. Before, what you had was kind of like overlapping panels. And when you took the top panel off, it also removed all the screws from the lower panel. So whenever the fan started, it'd blow out the top of the lower panel and you'd get a little bit of an air leak there, which would always throw off your combustion air numbers. So when they made this change, so now basically you have panels overlapping panels, but separated out the screw holes. So now I can remove that upper chamber panel to get access to that area, to that air shutter and to those other components without really disturbing that bottom chamber, which is actually a really nice feature.
You know, one other difference that I can see off the top of my head is if you were to go out and buy one of these from your distributor or whomever today, you would get a little bit different display on there. Now, the display buttons, they all work the same to get into each of the service parameters. Everything's the same the way you operate it. The one big difference that you will notice is in order to unlock the screen and actually be able to press a button to make things happen is you're going to have to slide from the left to the right hitting all buttons. So that's the biggest difference. So if you were used to unlocking an older type iPhone, it's kind of the same concept. So that's the big difference. But as far as how it's wired, how it's installed into the panel, all of that is the same, just a little bit different look.
All right. So now let's just start at the beginning. Like I said, we'll kind of walk this thing down the line here as far as the assembly process. So when they go to build the units, basically you start with, the first thing that goes on the line, which is the pallet. Then you start with your sheet metal base. And then the side panel. So basically you got kind of a one-piece wrap here, which would be your left and right sides as well as the back. Your Lockheed ceramic tile or the fiberboard material, which is your insulation, goes into it at that point. One thing about the ceramic tile I'll mention is it does not like to get wet. It's a pretty durable material, but the one thing it doesn't like to do is have a lot of water standing on it for a long period of time. That water will eventually cause the binders in that material to start breaking down and it'll start basically dissolving. Now, typically on a startup, you get a little bit of condensation on an initial start. That's fine. That's going to dry up. You don't have an issue. It's where you have a situation where maybe you got a leak in the heat exchanger and it's just constantly wetting that fiberboard material. That's when you run into a problem.
You know, Charles, back when I was in our tech service department, I had a gentleman call in. And I believe it was on maybe a copper fin tube, but realistically, everyone, the copper fin tube, the copper fin, this unit, the EnergyRite, they're all going to be serviced the same way. But this gentleman, he took his burners out. He was doing a cleaning, and he wanted to clean up his heat exchanger as well. So what he did was he actually took a pressure washer to the heat exchanger and absolutely soaked every bit of this refractory tile. So unfortunately, like Charles said, if this refractory tile gets soaked, it's going to start to break down. And if it starts to break down, chunks start to disintegrate essentially, or cracks start to form, that is essentially what's protecting that heat coming from those burners in that combustion chamber from warping the sides of the panel. And once you warp the left, right, back side of that panel or the bottom, that's a new unit. Those panels are not replaceable. The only replaceable panels are going to be the top and the front. So if something happens to those other sides, you're looking at a big issue there. So do keep all that in mind. Now, whenever you're looking in here, you're going to see some discoloration sometimes, a couple scratches, a couple of nicks here and there. I'm okay with that. But if the thing's falling apart, big cracks, that's what I'm worried about. So if you see that, don't put the unit into operation until that issue has been resolved and those pieces have been replaced.
Right. So yeah, just be careful about that. Yeah, using a pressure washer inside the cabinet is probably not a great idea. So I would avoid that. As you can see on the right-hand side over here in that insulation, you'll see a hole kind of right in this area. That would be for your sight glass. There is a material there. It's not glass, but we call it that. But that protects it, prevents the flue gases from coming out. That kind of gives you your viewport into the combustion chamber. So that way you can see the igniter, you can see the burners in operation, so you can see what's happening. Also, when you look over on the right-hand side, you kind of see this U shape. This is where the heat exchanger kind of sets down into. So when we go to this next slide here, now we see that heat exchanger mounted down into the unit. So as I said before, it doesn't slide out the front like we see with the other products. This one kind of goes down from the top side. That front header will be attached or secured to the unit itself. So you'll see this insulation material that goes around the header. That's going to be used to seal that up at that point. You'll secure it with a few different screws to hold that nice and tight. The rear header back here, though, is allowed to float. So it's not attached to anything. So it's going to basically, because you're going to deal with expansion and contraction as this thing heats up and cools down, that rear head's allowed to float around a little bit. So you're not going to attach that or secure that with anything. Now here we're looking at a completed heat exchanger installed in the unit. At this point, we've actually added our V baffles across the top of the heat exchanger. The whole point behind the V-baffle is basically just to slow the flue gases down a little bit, to allow them to be forced through the fins of the copper tube to give you better heat transfer. You've got a couple of brackets here that just hold those V-baffles in place. Those are primarily shipping brackets. Once you get it on the job site, if you took those off, no big deal. You don't necessarily have to have them for the operation. If for some reason we do have to clean the heat exchanger, we say, hey, it's fairly dirty at this point. You do want to pull those baffles off to get to the top of the heat exchanger. Make sure you brush that copper off really good. Vacuum it out. Primarily, you're going to use a stiff bristle brush. Whatever you do, don't use a wire brush or wire wheel on the copper because it will damage the copper. But also, if there's a lot of soot buildup on those fins, if you hit that wire wheel to that and you create a spark, it will actually catch on fire. You will actually start a combustion process at that point with that carbon. So you don't want to do that. So always just use that stiff bristle brush.
Absolutely. And this is something that we're asking you to do annually. So once a year, we are looking for this heat exchanger to be cleaned up. One thing that you do want to keep in mind, if for some reason you get in here and it's very sooted up and it's very blocked on all these copper fin tubes, you may in fact have to remove the heat exchanger from the combustion chamber itself. I'm not saying this is a normal thing, but if you do feel like you need to pressure wash it or something, just make sure you remove it from the chamber itself, get it, away from the unit. Also, sometimes we do get the question, well, can you use any type of cleaning solution or anything like that? Well, we haven't tested or approved anything here at the factory, but here's the deal. If you need to remove it and you need to pressure wash it and you want to run some type of solution cleaner over it, you can do that. But just make sure it's safe on copper and copper nickel if you have that option going on here. So just make sure you're running something clean on that. And I'd always recommend not leaving that solution on there. Make sure you wash it off before you do put it back into the combustion chamber.
Yeah, if it gets to that point and you got to remove it, just you don't want to hit it with that brush. It's going to be too much work. Just pull that heat exchanger out, like Jonathan said. There's different things out there. Just make sure it's safe for copper to use. Spray it on, wash it off before you put it back in. Make sure it's completely clean of that material because you don't know how that might react in the combustion setting. The heat exchanger that we do see in this particular picture is a non-ASME. The heat exchangers are available for either ASME construction or non-ASME construction. The difference is going to be the heads. The non-ASME will be a polymer header, whereas the ASME standard will be a glass line cast iron header. Now, the heat exchanger itself will use a standard two glass line headers. So you have that rear header, which will be a glass line cast iron, as well as the front header, if you will, that front attachment, if you will. The removable header, that's going to be your difference, whether it be cast iron, glass lined, or the polymer. Now, there is options for bronze. So if you do want to go bronze, maybe you got a saltwater pool application, bronze header is available, as well as what's called copper nickel tubes. The example that you see here is a standard copper heat exchangers. You can tell that by the nice shiny bright copper. So that's pure copper. But in the saltwater application, you do have the option to go to what's called a copper nickel, which is 90% copper, 10% nickel on the tube. It's a little bit harder tube. So you get in those saltwater applications, you want to protect the heat exchanger, go to a copper nickel with the bronze headers, you're going to have the max safety at that point. Now the picture that you see here, the header is actually upside down, so you can actually see the drains on the bottom of the heat exchanger, so you can drain it. I will also mention the EnergyRite is the only heat exchanger that we build today that actually has a gasket in it.
Right.
So that's something you do have to remember. If you're going to have a leak somewhere, the weakest spot's typically always a gasket. Unfortunately, because of the design of the head with that bypass in there, we can't avoid that. So we do have to use a gasket on this. So just be aware of that. If for some reason you overpressurize the heat exchanger, or if you got an issue that's going to create a leak, it's typically going to be at the gasket, which also means that it is replaceable. So you can pull that head off and replace the gasket if you need to.
Right. And that's always a good point. Now in saying that is the only gasket that's involved with this heat exchanger. As far as where the copper tubes go into the cast header and footer, those copper tubes are actually swedged into that cast header and footer. So there's no gasket in that area. A little bit about those copper tubes, though. They start out as just a more of a thicker copper tube, and we actually extrude those fins from that thicker copper tube. It thins out the inner wall of the copper tube, but those copper fins that you see on this heat exchanger, what that does is that gives us a little bit more surface area so we can really pull the heat in from those burners and throw those BTUs in towards the water. So that's why you see that. And so a lot of people, I've had the question in the past, well, are those copper fins, are they brazed on, welded on, or what have you? No, they're not. It's one solid piece. They're just extruded from a thicker piece of copper tubing. So do keep that in mind. And that's another reason why we do have to keep this stuff cleaned up once a year, because, those copper fins, they're pretty close together, and, things can build up over time in between them. So we like to make sure that those flue gases can really pass in there. You saw on the previous slide, we do have the V baffles on top of it. And like Charles said, that's to keep the flue gases, was to slow them down for just enough to where we collect all the heat we can without slowing them down too much to where we start to condense inside of this cabinet, because this is a non-condensing unit. So those flue gases, those acidic flue gases could form into a condensate, and they can eat away at that copper. So if you ever get into this heat exchanger and you start to see, hey, I'm seeing a lot of green material or black material on this heat exchanger, that's a sign that this unit is condensing, and we need to figure out why. Is there something going on with the bypass? You may have, our flow rate slowing down way too much. What's going on here? So in that situation, you may have to take that front header off to inspect that bypass to make sure it's not coming apart or anything like that. Draft is another big thing for those indoor installations, because this unit's going to come to you ready to be installed outdoors. So you do have to put an indoor kit on it to where you can vent the unit. So if it's not drafting right, and you have those flue gases pooling inside of that cabinet, they're going to sit there and condense, and they're going to start to eat away at that copper heat exchanger. So if you ever get in here, those are a couple of things that can cause that green buildup on top of that heat exchanger. So, do keep all of that in mind as you're going through here.
Yeah, a couple of things about flow rates. The maximum flow rate for these heat exchangers, and it doesn't matter whether it's ASME or non-ASME, is 100 gallons per minute. And we can see the pressure ratings, 50 max for the non-ASME, and that's because of the polymer header, 125 for the ASME. But your flow rate's 100 gallons per minute maximum for the larger, or for all models. Your min flow rate's dictated by the size and the bypass that's inside. So we look at the input. So real quick, easy way to determine what your minimum flow rate is, take the first two numbers of the model number. So if it's a 200, it's 20 GPM is your minimum. If it's a 400, 40 GPM is the minimum flow rate. So it's real easy to determine what that min flow rate is. And the reason that's important is because how the bypass works. So as your water comes into the heat exchanger, and I'm going to just go over here to another slide. Skip that real back. Here's our front header for our non-ASME. So if I look at my inlet water as it comes in on this left side, only a certain amount of that water is actually going to go down through the tubes. The rest of it's going to be bypassed. So whether it's, I'm bypassing 10 GPM or bypassing 50 GPM, I'm bypassing a certain amount. Only a little bit of water is actually going to go down through the actual heat exchanger tubes. And the reason for that is we're going to superheat that water really hot. Okay, and that is to prevent the condensation. You get those flue gases out of that dew point range by putting so much heat into the water. Now we're going to superheat that water, so that means then I've got to cool it down on the other side. That's why I'm diverting or bypassing that water from the inlet to the outlet. So there's a spring in there. That bypass is basically spring loaded. So depending upon what your flow rate is will dictate how much you depress that spring and how much water you divert over across the plunger, if you will. So basically there's a spring holding a plunger in place. So when that water hits that plunger, it's just pushing back on that spring. So that's going to kind of dictate how much you're diverting. So as that super hot water comes out of those tubes on the discharge side, it's mixing with the cooler pool water, and that brings you out to a manageable outlet temperature. If you're looking at delta T's, and a lot of people like to get hung up on delta T's. If you're just looking between what you would see at the inlet and outlet water connections, it'll be between a 10 to a 14 degree delta T. Now, realistically, that's not a true delta T, because I'm not really looking at what the inlet versus the outlet of the tubes are. What I'm seeing is a blended temperature there on the outlet side. So I try not to get too hung up on that delta T unless I just see something really, really, really weird there. Again, I prefer to have some sort of flow sensor monitoring what the flow is coming into the unit. So I can't really tell by that delta T what the flow is. It won't tell me, whereas I can see that on other products.
Yeah, this heat exchangers, it's I don't want to say it's weird, but it's a lot different from, you know, other copper style heat exchangers that we have, because you're not seeing a full pass through the heat exchanger. You know, you're not seeing water coming in the inlet, passing through 4 passes in the heat exchanger and coming straight out. So it's almost like the delta T that you're seeing it's false, because it's a mixed temperature. Okay, but it's a semi guideline to what you can look at, because unfortunately on a lot of applications out there, people, you know, the flow meters are just not installed when they should be, you know. So that was just a way for us to give you a ballpark. Hey, you've got a correct flow rate, but you really need flow meters at the end of the day.
Exactly. Yeah, so if I saw something like a delta T of 2, I'd be concerned, or a delta T of 30, I'd be concerned. Right?
Exactly.
So those would be the things I'd be watching out for. But again, the 10 to 14 kind of gives you a ballpark, but realistically, I'd want a flow meter there, so that way I know exactly what I'm doing here. When we look at this connection, again, this is our polymer header, so this is our non-ASME. Your inlets on the left, outlets on the right, which is kind of actually reversed from our other copper products. It's a little different there. You see your inlet and outlet water sensor screwed into the head. I believe the current models actually use stainless sensors. Those are, I think, looks like brass. Current models are stainless. We have switched those up a little bit. You've got your water pressure switch back there. That's your standard water safety device that's set at 5 PSI as it leaves the factory. If you want to use some other safety, such as a flow switch in conjunction with this, that's perfectly fine. You can tie that in, you can wire that in as an auxiliary safety, so you do have that ability. And then over here on the back side, you do have your automatic reset high limit, which is basically monitoring that kind of that temperature coming out of those tubes, so make sure we don't get it too hot coming out at that point. So these are our connections on the non-ASME. And if we look at the ASME, very similar, again, just a different design on the head. Still got the same inlet outlet connections, still the same sensors, just different locations. A little bit with that outlet sensor kind of stuck in the side there. Same thing for that automatic reset high limit. Come back here on the back a little bit. So a little bit different there. And then you also see a relief valve here. So that's something you typically don't see on the non-ASME.
And also on the ASME header, you can actually see, I forget if you pointed this out or not, kind of follow along with me. You can see this this bronze plug that's screwed into the right side of the header where the outlet is. So that is basically, that plug turns into a stem, and that stem goes through a spring and attaches and it puts pressure onto the bypass that allows water to flow from the inlet to the outlet when flow rates are starting to increase. Right. So that actually has to do with your bypass inside of that header. So you can't see that on the non-ASME because everything is internal. On this one, you can see a part of it on the outside, but realistically, if you thought there were some issues, you're still probably going to have to take the header off and visually inspect and make sure everything's going on.
Exactly. If you wanted to get to the actual plunger, yeah, you'd have to remove the head to get to it at that point. So, all right. So that's our heat exchanger. We'll see here. We got any questions so far? It's been a quiet group. I got no questions coming in. So again, if you've got something you want to ask, shoot them to us so we can get them answered for you. All right. So now we're going down the line. So again, we've got our heat exchanger set into the heater. Now we start adding the other components. So now we got their outer side sheet metal panels. We've got our combustion chamber door going in with our burners attached, gas train going in, our fan assembly. So right now we've got other components going into it right now. First thing we'll talk about real quickly is the burner. These are rated at 50,000 BTUs each. So if you, for some reason, don't know the model number, maybe it's washed off on the rating plate, and that does happen. So you need to know the size. If you know the number of burners you've got in the heater, you know what size you've got, right? Each one's 50,000 BTUs. So a 200,000 BTU heater's got 4 burners in it, right? Yep. So I know what we've got. It's easy to deal with.
I love that last bullet point. Lochinvar special design. That I like the way we did that.
Yeah, special design. So basically, when we work with the burner manufacturers, And there's other manufacturers that use burners. They'll look very similar to this. Everybody has their own little tweaks to maybe the port pattern going across the top of it. But one of the unique things about the burner, excuse me, is that inside the burner, and you can't really see it in this picture, but inside this burner, there's what's called a Venturi Baffle. All right. This Venturi allows that gas air mixture as it comes in to go down to about the midpoint of the burner. All right, at which point that baffle shoots the gas air mixture down into the bottom of the burner, which allows it to spread out and then come up through the burner ports on the top. So what that does is basically it gives you a more balanced gas air mixture across the surface of the burner. So it gives you a more even flame. If that baffle wasn't there for some reason, what you would end up with would be a very tall flame at the front of the burner and then a very short flame at the back, because the gas air mixture wants to go the path of least resistance.
Just like water.
Yeah, just like water.
Yep.
So it's going to go through those first openings. So you end up with that huge flame at the top, very short flame at the back, and then you're going to end up overheating the burner, burning the burner up.
And that's that Venturi tube is like Charles said, it's flipped 180 degrees from the top burner ports that you're looking at right now in this picture. So let me give you a little information about how to service these burners. So when you're ready to do your annual, so once a year, I need the burners pulled, cleaned out, and I'm about to tell you how. I need that heat exchanger cleaned up like we discussed earlier in the presentation. So that Venturi baffle is exactly why I can't just blow air through this burner when I take it out to clean it, okay? That baffle inside, I got to have some type of fluid coming in contact with it, so that way I know 100%, hey, its ports are clean, I'm good to go. And water molecules are larger, so that's just going to clean it a little bit more, right? So that's what I need to be done once a year. Now, sometimes I get the question, can I put it in a bucket of hot soapy water? Yeah, you can do that. Let it sit. But then again, I want you to flush it out really well. And the one main thing I try to throw out there is just, I don't want this burner put back into the unit full of water. Shake it out, let it dry out, blow it out after that if you want to kind of put some of that water out. Yeah, once a year, clean it up real well. Now, don't get this confused with a lot of our other product lines, such as, say, a Crest, an FTXL, or a Knight. Those I do want blown out once a year with, say, compressed air and nitrogen. You can wash those, but we direct people to blow those out with compressed air because they have what's called an Alcro mesh that's welded to that burner, okay? It's designed to be blown out. But this one, I want you to remove it, flush it out real well with water. And don't forget about the burner gaskets, because I'm here to tell you, as soon as you show up on a job site and you don't have them, every one of them is going to rip. We all know how that goes. So do keep all of that in mind.
Now, the burner that you see here in this picture, you'll also notice up here at the top, there's kind of like a little brass fitting. You'll have one burner in the bunch that will have that fitting, and that is for our air hose to connect to from our air pressure switch. We'll talk a little bit more about that in a second as far as what the air pressures are that we're looking for. Now, as far as damage to the burners, what causes damage? Primarily, you've got two things that will cause damage: either thermal stressing, which will crack the burners, or the burners just get too hot, they overheat. Now, your thermal stress is generally due to short cycling, right? You're basically starting and stopping too rapidly. That metal's expanding and contracting. So that burner's going to sit there and basically move. It's going to float up and down, which will eventually create stress fractures across the surface of the burner if it's done too frequently. Eventually, those stress fractures will get bigger and bigger and bigger, and then you'll basically just fail the burner completely at that point.
Absolutely. Something else to keep an eye on, whenever you pull these burners out, I also want them, visually inspected. So if you see some type of cracks, dents, big dents, voids, things like that, I don't want you to put that burner back in and put it back into operation. What I want you to do is get a replacement burner. And then once you get that new burner in there, hey, you're good to go, get it back into operation. Also, if you were to pull if you were to start to pull burners out and you see multiple are cracked in the same location, that's a good sign you may be condensing, and that condensation is constantly dripping on that portion of the burner, causing it to crack. So again, we talked about how the bypass works. That would be one of the first places I would go back and look at.
Okay, Jonathan, I see that we've got someone here who's got his hand raised. Eric Green, I'm going to give you the permission to talk if you want to. So if you've got a question, you can unmute yourself. You should now have that ability.
Yeah, quick question. Those burner gaskets, are those unique to Lochinvar, to the EnergyRite, or are those generics?
Well, as far as the gaskets, they're kind of generic for our products. So basically, you could use it on the EnergyRite, you could use it on the Copperfin 2. So yeah, it'd be probably unique to Lochinvar per se, but it's a similar gasket that we use on other products. All right. So hopefully, Eric, that got your question.
Thank you.
All right, cool. All right. So good question there. Now, as far as, so you got the thermal stressing it causes them. You've also got, again, burners overheating. Primarily the reason for burners to overheat would be dirt, right? As your fan's running, whatever's in the air, that fan's going to pull in, it's going to end up in the burners. Your burner is the ultimate filter. So as those burner ports start to get plugged up with dust, dirt, lint, whatever, okay, basically then you're reducing the amount of gas and air that can come through that port. So what will then happen is those ports start getting plugged, that flame will start to pull into the burner surface slightly. And as that flame comes into the burner surface, that's when you start to overheat it. And that's what's going to cause the damage. Ideally, the flame should never come in contact with that stainless. It's always going to be setting off the surface. All right, so when you start plugging those ports up, that's when you get that damage, that heat starts pulling back into the burner. That's when you create that issue. Other issues that will cause overheating, again, just a bad gas air mixture, right? You're overfiring it, too much gas, not enough air. All right, so either from air pressure or a lack of oxygen, or you got a bad vent system, not enough draft.
Yeah, and another thing that I always do, and this goes for not just negative draft appliances, this goes for a positive category 4 appliances. I always look, and just to have a look at the flame inside the combustion chamber. I want to see a nice, strong blue flame that's not pulsating or getting lifted too high off of the burners. If you start to see, what looks like a campfire sitting on top of your burners, you have something going on. You have, again, like Charles said, you've got a blockage. You've got something. You've got an improper gas to fuel mixture going, or gas to air mixture entering that combustion chamber, and we're going to have to figure out what's going on. So do keep that in mind. If you see real red, orange flame on appliance, your CO is probably high enough to kill birds in mid-flight over the stack. So, you might want to shut it down and start checking a couple of things. And one thing that I always throw out there, if it's, if something's going on with the unit, it's not lighting, terrible flame, something like that, don't just start with adjusting gas valves or adjusting, air pressures or anything. Start with your cleaning and then set the unit up, and you'll probably be okay.
Exactly. Yeah. So if it's been in for a long time, start with the cleaning first before you go starting to set air and gas, because if the burners are dirty or the heat exchanger is dirty, it's going to throw all those other numbers off. Now, something else that could cause a burner failure, though I hope you would never do this, would be if you installed the burners in upside down, as you see in this picture. This did actually happen. You've got to try really hard to do this because the screw hose will not line up, so you do have to put in additional screw hose to make
self-tappers.
Self-tappers. And unfortunately, that's what happened in this scenario. So, yeah, please don't install your burners upside down.
I believe I know who did that, too. I won't say, though.
Yeah, we won't say. We know who did that one. All right. Again, as Jonathan mentioned, cleaning the burners is just as simple as washing your car, right? Now, since Kevin Watts is another one of our trainers. He's not in here, so we can make fun of him. Well, I won't make fun of him because that's his car, right? So obviously he's doing something right.
Yeah, no lie.
Yeah, so that's Kevin washing his car there.
Obviously, I'm underpaid. I need a raise, Charles.
Yeah, I know. Don't we all? Don't we all? All right, so let's get into the gas train. So now we talked about the burners. Now we got to see what's feeding the burners, right? And that's our gas train. So up top, you've got a single combination dual seat gas valve. So it's your combination valve regulator. You've got your individual orifices going down through your manifold. For difference between natural gas and propane are going to be the orifices, obviously, the size of the holes in the orifice, as well as the gas valve would be a different gas valve. Something else that you also see up here on top will be this gas pressure switch. Now you'll notice that is for models 250 to 400,000 BTUs, natural gas only. The only reason that switch is there is to meet a certification requirement. One of the things that we have to go through when we go through our certification is what's called a low inlet gas pressure test. So basically, depending upon what our manifold pressure is, you have to be able to run at a certain minimum number above that. Unfortunately, the models 250 through 400 on natural gas will not pass that test. They cannot fire and run based on this test procedure. So because of that, that's why that hazard gas pressure switch there is to shut the heater off if you hit to that number. That's the only reason for the switch. It is an automatic reset, so there is no manual reset to it. If for some reason you wanted a manual reset low gas pressure switch, that could be provided, but most cases that's generally not a requirement for anything under 400,000 BTUs.
You know, two things I do like to point out when we're looking at this picture. Number one, you know, Charles mentioned the, my mouse here, Charles mentioned the orifices down here. It's not a bad idea just to make sure those are clear of any dirt or debris or trash or anything when you do your annual, because you're going to have to take this inlet gas manifold out anyway, so it doesn't hurt. Also, another thing, follow along with me. This gasket, a lot of people call it a donut gasket, but the professional quote unquote name is escutcheon gasket. And do not ask me to spell that because I will butcher it to death. So that is what's sealing the inlet gas manifold where it penetrates through the top of the combustion chamber and goes down to your burners. That's what's sealing the air chamber down there. So if you ever are dealing with nuisance air pressure switch lockouts, low air lockouts, make sure that thing is sealed. Something else, don't take a screwdriver and start to poke down on it or anything, because at that point you're probably going to puncture it. I just generally use my hands to kind of clip it in place. It generally isn't too hard of a thing to do. So again, air pressure switch issues, that's one thing to check. And just make sure those orifices are good and clean when you do your annual.
Yeah, the orifices, for some reason, I don't know, especially LP, spiders love LP for some reason, and they will build nests in those orifices, so they'll plug them up. So yeah, that's a good point. If it's been setting off for the season, yeah, go through and clean those out and make sure that those are unobstructed. Now, how the valve works and how we're going to set this valve up, this is what's referred to as a reference gas valve. All that means is basically that the regulator is referencing the front chamber, right? So it's referencing some other area. So what we're doing is basically taking and adjusting the spring in the regulator like you would any other regulator. You're basically turning that spring in, pressing down on a diaphragm, which opens it up to allows gas to flow. So we're going to preset that at a certain pressure. Then, based on the pressure that's in this reference hose here, that's going down and connecting to the front chamber, it's looking at the pressure that the fan is blowing down into. All right, it's taking that pressure and pressing that regulator down even more. All right, so if you get a slight fluctuation in the air pressure from the blower, voltage issue, fluctuation, back pressure in the stack, something of that nature that might cause that pressure to change just a little bit, it's going to reference that to the gas valve, so your manifold pressure will change just a little bit to match it. So you're trying to maintain that balanced gas-air mixture going into the burner. Now, if your air shutter is just, if you don't have your air shutter set correctly and it's just way off, this isn't going to compensate for that. All right, so you're going to make sure everything is set correctly, and then again, slight fluctuations during normal operation, this will help compensate for it.
So basically what you're telling me is maybe if I get a weird wind coming onto an intake or something like that, I can compensate for that little bit of extra air up to a certain point and not throw my combustion off too much, right?
Exactly, and that's all it's there for.
Yeah.
Basically just help maintain that balance. Now, how much pressure should we have on that air side? Well, what we're going to look at is how we measure this. So if you've got a manometer that's got two connections on it, it's really easy to do. You hook up to the outlet of your gas valve, and then you hook up to that air hose that's going down to that deck. And you're looking for a difference between those two pressures, and that's called the net manifold. Now, typically the way we set these up in the field, the way I set it up, I'm going to set that deck pressure first. I'm going to adjust my air shutter to give me the deck pressure that I'm looking for. 1.4 to 1.6, somewhere in that range is what I'm looking for, right? So I want that pressure right in that range, 1.4 to 1.6 we'll call it. I think the manual says 1.8. I think that's a little on the high side. So 1.4 on the low end, about 1.6 gives us a nice happy medium. Once I've got that air set to where I want it at, as far as that deck or that chamber pressure is concerned, then I can look at that manifold pressure. Now, if you've got to have a single tube manometer, and a lot of people do, and that's fine. You set your deck first, then you hook up your manometer to that outlet tap, and then you fire the unit up. Now, when the valve opens, what you're going to see there is what's called the gross manifold pressure. All right, so that's the pressure that the regulator is adjusted to, plus the air pressure on top of it. All right. Now, I know that the air pressure on the deck, let's say, is 1.4 inches. Good. All right. Now I'm looking for a net manifold pressure of, for a natural gas heater, 1.8 inches. That's what I want that regulator adjusted to. So if I take 1.8 and add 1.4 to it, that gross pressure, or what I should be seeing coming out of that valve, would be 3.2 inches. You got to do a little math here. Unfortunately, I'm sorry about that, but you got to do the math. So I'm looking for 3.2 inches. So if I've just got a single tube manometer hooked up to the outlet of the valve and that valve opens on a natural gas heater, 3.2 inches is what I should see. Again, if that air is set at 1.4. Now,
so basically what I'm going to do if I'm setting this thing up, I'm going to take the gross manifold pressure by itself. I'm going to write that number down. And then I'm going to take the air pressure by itself that I've already set, write that number down. And I'm going to subtract the air pressure from my gross manifold pressure, which will give me my net manifold pressure, which is how much gas only I have going into the burners, basically.
Yeah, I know it seems like a lot of steps, but it's not that hard.
So basically at the end of the day, go out and buy you a dual port manometer, then you don't have to deal with this.
That's exactly right. Now, if for some reason we do need to adjust the setting of that regulator, right? Because we know the air is fixed. We got the air shutter set. We got the air delivering what we want. But if our number's off, then we got to basically adjust the regulator. So to adjust the regulator, while the heater's running, we're going to pull that cap off. Now, here's what's going to happen. When you pull that cap off the regulator there, now I'm taking that air pressure off of it. That manifold pressure is going to drop. You're not going to have enough gas coming through there to sustain the flame. It's going to drop out. So if the heater's in operation, if the burners are running, flames are going to go away at this point. Now, if the unit was running, the unit's going to go, hey, we were running, we lost the flame signal, so let's go back and try to relight. Now, you've got a little bit of time here, so you've got to go through a post-purge period, then you're going to go through a pre-purge period again. So that gives you about 40 seconds there to be able to make your adjustment and to get that screw cap back on before it lights. Now, if you're fast, you can do that. If you're like me and I pull that cap off, it's typically going to fall down somewhere in the cabinet, roll across the floor, and I can't find it. And it's going to lock out before I can get that cap on there. So just have some patience with it when you do that. Just make sure, again, because that cap, if there's a drain anywhere near the heater, that cap hits the floor, it's probably going to go down the drain. So just be aware of that. You
know, two common mistakes that I'm not going to say they're common, but there's certain things that I've seen. You know, people call me, hey, John, I'm having some flame failure issues. And, you know, we'll start going through the normal things. The first thing I'm going to check, has it been cleaned in the way, you know, we've already discussed in this presentation? And then we're going to start checking a couple of, you know, we're going to see what our inlet gas is. We're going to see what it drops to when the valve opens and all that. One thing that I have happened in the past is people were messing around with the unit before they gave me a call, and they actually took that adjustment cap off, and that's why, you know, it wasn't lighting. And sometimes you forget about that cap. So, you know, one thing I just want to say is make sure that cap is on there. Also, another easy mistake that's been made is just simply making sure that gas valve is in the on position. You can see the top of the gas valve there, and you can see on and off position. Make sure it is in the on position, because those are easy things that we, you know, blow by because our mind goes to complicated instead of the simple things first. So keep all that in your back pocket.
Yeah. And it's like any other regulator. If you do need to make an adjustment, you turn it clockwise to give you more pressure because you're pressing down on that diaphragm, counterclockwise to give you less pressure. Don't go nuts with it. Just make a small adjustment with it, you know, see where you're at. Because typically they're not going to be that far off. You're not going to see that much movement in it. All right. So I'm going to stop for a moment, see if we got any questions. It still seems to be quiet. I got nothing on the Q&A. So that means we're either doing a really, really good job or we've put people to sleep, one or the other. I don't know which.
Could be a little bit of both. I don't know.
Could be a little bit of both. So, all right. So hopefully we're doing a great job. All right. So igniter and flame rod. So now we've got burners, we got gas. Now we got to have something to light this thing with. Now this model is what's called a direct spark system. So we're not lighting a pilot. I don't have a hot surface igniter here. So it's basically a direct spark system. So I'm directly lighting the burner flame off of the spark. So the control module sends down about roughly a 6 to 10,000 volt spark down to this igniter. Now this igniter that you see, I believe this igniter I think is an older picture here, but that's fine. It still serves the same purpose. Same concept. So basically sends like a 6 to 10,000 volt spark down to that thing. You get this nice little blue spark going across the tip up here. That gas air mixture comes out of the burner, hits that spark, and it lights off. Now, once you do that, you've got your flame rod sitting over here doing its thing, looking for a flame signal. Now, the control module, unfortunately, doesn't tell you what that signal is. However, if you wanted to put a microamp meter in series with the flame rod to the control module and look at that flame signal, you could do that if you wish to do so. Typical flame signals probably going to be anywhere between 4 to 8 microamps.
Right.
You might see them go higher, and if it goes higher, that's fine. It's not a big deal. You need at least a minimum of 1 microamp to prove the burner flame in. So if you got anything less than 1 microamp, basically you're going to flame out. And you get 4 tries for ignition because they're under 400,000 BTUs. Right? You get 4 tries for ignition before you will go into what's called a lockout or a flame fail condition.
You know, another way to check your flame signal to make sure you've got a strong flame is simply go back to that sight glass and just make sure that, you know, you've got a nice strong blue flame, not pulsating like we were talking about earlier, because like we just said, the control is not going to tell you the DC microamp flame signal that it's receiving. And you'll see later, it just says we have a flame or we don't have a flame. It's yes or no.
Yep. Now, as far as rods and igniters go, you know, some people will just replace them as part of their annual maintenance. And if you want to do that, be my guest. That's totally up to you. All right. But realistically, you don't need to replace the rods unless they are physically damaged. So unless the rod is burned off to where it's no longer setting in the flame or the insulator's cracked or something like that, there's really no reason to replace the rod. If they're dirty, clean them up. Right. And if you want to clean them, whatever you do, don't use sandpaper, right? Why do we not want to use sandpaper, John?
Well, that sandpaper could potentially reshape, put grooves in that igniter or that flame sensor. And the one thing about sandpaper is it has the potential to leave a little bit of sand on that rod itself. And whenever you heat up that sand, it forms into glass, which becomes an insulator. So that will mess up your flame signal, and it's just going to sit there and not light. You know, I don't know how often that happens, but it is a possibility. So, you know, like we were talking about, we typically like to use some type of Scotch-Rite. Not a big fan of metal wire brushes because, again, I'm not trying to reshape or reshape this igniter or flame sensor. I'm just trying to knock the dust off it a little bit, just knock the surface off. So a lot of people, I'll tell you, you know, Scotch-Rite I'm good with. Some people use dollar bills. If you've got deep pockets like Charles, you use $100 bills. He gives the raises to himself. Canadian money doesn't work at all, so it's plastic. So maybe somebody got a laugh out of that one.
All right. So we got our igniter and a flame rod. So now we start adding the wiring to it. So now we've got all of our main components. Now we're going to start wiring everything up, and we're also going to add this air pressure switch here. All right, so that's a differential pressure switch. So when we look at that, basically I'm looking for a differential here. So if I was to measure this, I'm measuring not only the difference, I'm measuring the difference between the deck pressure versus what's going down to that burner. So remember the burner with the little barb on it? Okay, that's measuring the combustion chamber pressure. That basically is what we're looking at there. So I'm looking at the difference between those 2 points. Now, realistically, the pressure on the burner, that little barb, that pressure there should be a negative. All right, because you got air going through that burner, it should be pulling a negative at that point.
Very slight
negative. So I'm looking for a differential between 1.65 to 1.8 inches. That's a little on the high end, but 1.65 to 1.8 is what I'm looking for here. Now, if that pressure on that burner tube, or if that pressure there goes positive, right, then your differential starts to shrink, right? So if I had in that front chamber a pressure of 1.5 inches, right, and then off that burner, I had a positive pressure of 0.4 inches. Well, my differential now is 1.1. I've got a problem because that switch isn't going to make it that. Now, the problem is when people come in, they get hung up on that differential pressure. They say, oh, the low air pressure switch isn't making. All right, so they measure the differential pressure, and they see the differential pressure isn't where it's supposed to be. So the first thing they want to do is grab the air shutter, okay, which is right over here on this fan. They loosen up the 2 screws. They pull that air shutter wide open. So you put more air down into that front cabinet. Now your differential gets closer. The heater might light, but typically what you're going to end up with will be a hard start or a rough ignition because now I've leaned that gas air mixture out too much. I'm putting way too much air down in there into that combustion chamber than what I really need. So a lot of times when this thing goes off on low air, in most cases, what you're dealing with is something putting a back pressure on the burner.
Some type of blockage, right? Some
type of blockage, a dirty burner, sooted heat exchanger, a venting issue, something of that nature is more often the cause of a air pressure switch lockout condition. So, or In some cases, I've seen this, people just pull the front door off of it and try to fire it, and that doesn't work either.
Oh, absolutely. If yeah, I mean, and you know, if you've got gaskets that are torn or screws that are missing, it's going to do the same thing.
Yeah.
And here's one little other piece of advice I want to give you. I don't remember if Charles said this or not. If you are the one doing this startup, or if you clean it and set this thing up, I want you to use a Sharpie, and I want you to mark where you had that air shutter to give you the proper air differential to where it ran fine, okay? Because that if you come back, you know someone's came behind you and pulled that thing open to basically Band-Aid a dirty burner, a blockage, a venting issue, or something of that sort.
Yeah, people get, when they see that low air switch fault, they see that low air switch open fault, you know, there's a lot of assumptions and they make. A lot of times we'll just assume it's a bad switch.
Oh, yeah, that's
the
biggest
all the
one.
Time. And it's typically not a switch issue. So don't replace a switch until you actually measure the pressures and see what you're dealing with.
Yep,
okay?
absolutely.
Now we start looking at the wiring. Now the heater itself comes equipped for either 240 or 120. As it leaves the factory, the little jumper here should be in the 240 volt position. And that's kind of important, right? Because why do we want to do that?
Yeah, so here's what I've seen in the past. And now this is something else I want everybody to pay attention to. It may help you out on a brand new startup. So you see that 240 jumper plug comes in the jumper plug comes in the 240 position. What I've had happen before is on startup they had a low air pressure switch issue. You know, APS open, low air, it's not working, lockout. But they wired it for 120. They forgot to take that 240 plug, or that jumper plug back over to the 120 position. So what'll happen in that situation is that fan, it'll get power, but it will run very, very slow. Okay. And it won't have enough energy to pop that pressure switch closed. So, hey, just something else to keep in your back pocket. Brand new startup, low air situation, and you barely hear that fan run, check that jumper plug just to make sure. And one of the big reasons we put it in the 240 position is if you had it in the 120 position and you wired 240 to it, you may smoke something. In 240, you're not going to if you put 120 to it.
Yeah, you release what we call the magic smoke from the board when you do that, and that's a bad thing.
And it don't go back in.
It doesn't go back in. All right, so you got your big red on off switch right over here, and then you got your terminal strip. Now, the terminal strip, you got your first two terminals there, X and B with the jumper. This is where you're going to wire in any kind of remote safeties. Again, like I said, that the external flow switch, if you wanted to add it, or some other pressure switches or some other device that might need to be added, that's where that's going to go. The other three terminals, your R, your WP, and your WS, those will coincide with either a 2 or a 3 wire remote device. To use those, we will have to do a little programming in the control. We'll talk about that just momentarily as far as their functions, all right? So now we've got our control panel on, we've got everything wired up, it's ready to go. So the last step on the line will be, they'll take it, they'll actually hook it up, they're going to run power to it, they're going to run gas, they're going to run water, they're actually going to fire the unit up, and they're going to do the settings, right? So the manifold pressure is going to be set, the air pressure is going to be set, everything's going to be fire tested here at the factory, and it's going to be good to go. Now, like I said, once it gets on the job site, hey, it travels across the country in the back of a truck somewhere. It gets on the job site, you stick, 40 feet of vent pipe on it.
Oh, yeah, absolutely.
Things are going to change a little bit. And that's why you've got to go in and measure, make sure that the air is set correctly and your manifold pressure is set correctly, because they're going to probably change just a little bit from here, what we had at the factory.
Right. So just come prepared when you are going to do a startup. You may have to have a manometer to check some pressures and slightly adjust them. Yep. Just remember, air pressure first, and then your net gas, in that order.
Yep, exactly. All right, now, as far as the control goes, as Jonathan mentioned earlier, that display. So, the biggest difference between the second gen and the third gen is pretty much the control itself. So we went to a slightly different integrated control module. So it's basically your thermostat, control module, all built into one with the display. So it's basically all one assembly. So when you first power it up, the display will be what's called in a lock condition. So to unlock it, to be able to use the buttons or to get into the parameters, you do have to basically do what's called a finger swipe, going from the pull spa, working from left to right, down through your up, into the reset menu. So basically you're just going to swipe your finger along that path, and that will unlock the display to allow you to make changes. Now, there is another layer of protection. We can actually activate a passcode feature that would require you to actually put in a passcode if you wanted to get in to play with it. So we can do that, and we'll show you how to do that in just a second.
And then, you know, if you want to change your temperature setting, your set point here, you're going to have to unlock it like Charles said, select pull or SPY, and then just simply press the up or down buttons, and you can change your set point that way. So if you need to know how to do it, it's very simple, and that's how you go about doing that.
Exactly. Now, there are two menus within the control. You have what's referred to as a setup menu and then the service menu. Setup menu is going to be our adjustable programming items. The service menu is basically just information telling us what's going on with it. So to get into the setup menu, basically just press and hold that menu button for 5 seconds. Once you do that, you're going to go into the first parameter. Now to scroll through the various parameters, if you will, you basically just you're going to press that menu button. You're going to keep pressing that menu button.
Keep tapping it.
You're going to keep tapping it to roll through your various adjustable items. If you land on something you want to make an adjustment on, use that up and down arrow key.
And then basically to save most of this stuff, you just exit out of the menu and it's going to save it. So, you know, if you lose power while you're saving it, or excuse me, while you're trying to programming it, it's probably not going to take it. So, you know, go back in and get into it, then exit out of the menu and it'll store that parameter.
Exactly. So just make sure you press that pull SPA button to save your parameters once you get done. Now, as far as the parameters go, there's not a lot of them. The first one that you're going to see is the pull SPA remote. So this goes back to that terminal strip, the R, the WP, WS terminals. So again, if I want a 2-wire or a 3-wire system remotely to be tied in some external control, which is perfectly fine, we've got to come in and activate it. We got to tell the control to be looking for the wires on those terminals. Now the default is disabled. So that means it's ignoring it.
You know, back when I was in tech, this was kind of a common call on startup, or in general, really, because people like to play with controls sometimes. Call was, got an ERN 402, can't get this thing to come out of standby, will not fire. And what it ended up being a lot of times is somebody got in there and played with the control and they programmed it to have a 2-wire or switch for a 3-wire system, when in fact they didn't have any type of control wired to it. So it should have been on disable to ignore those other 2 remotes. So keep that in your back pocket too, because that has made people stay on a job site for several hours and replace boards before. So just saying.
Yeah, just make sure, if you activate the features, there's got to be something wired across those terminals to tell the control what it's using.
You got to have that closure if it's looking for it, or it's going to sit there dumb and happy.
Yep. The next item is differential. So again, this would be how many degrees the temperature has to drop from set point before you actually initiate a call for heat. So in this case, default setting is 2 degrees. We've got a pretty wide range here from 1 to 15. 2 is a good number. Again, you don't want to go too wild with it, because especially in a pull setting, you know, if you put like 10 degrees there, and then let's say my pull set point was 80, that means it's got to drop to 70 before it kicks off.
That's a big swing too.
Yeah, that's a pretty big swing. People are going to notice,
and especially in a pull.
Especially in a pull. So again, keep that range kind of tight, if you will. So again, 2 to 3 degrees is probably where you're going to ride with that one. Now, I don't see too many people adjusting that particular parameter.
It's crazy how pull applications change from like boiler applications, isn't it?
Very much so. Your third one there is your temperature scale, either Fahrenheit or Celsius. As it leaves the factory, it's Fahrenheit, obviously. If you're in an area such as Canada or some other area and you read by Celsius, that's perfectly fine. You can flick that over, do that. Just don't ask me to do the conversion, because I cannot do that in my head. Sorry, there's too much math involved.
That's what Google's for.
That's exactly right. Then you've also got the ability to restore the defaults. Now, again, not that many parameters here to restore, but if you just want to come in and put it back to factory settings, you can put it back to factory settings by the restore defaults button. Now, if you want to add that extra layer of protection to prevent people from actually changing things, now we can come in and put in a passcode. Now your default is 1, 2, 3, 4. Pretty simple if you activate it, but I would say if you're going to use it, somebody's probably going to change it, right? So to lock the keypad, you got to press the up and down button simultaneously for 5 seconds. So use your 2 thumbs, 2 fingers, whatever, hold those 2 buttons down for 5 seconds. At that point, then it's going to bring up the lock keypad screen. So that's going to give you 4 digits to work in. All right, you're going to work from left to right. You're going to use your up and down buttons to adjust that first digit on the left side to whatever number you want, from 0 to 9. All right, press the menu button, move you to the next digit. You're going to keep doing that until you get your all 4 digits in. All right, and once you get that 4th digit in, press that menu button. It's going to lock the keypad. It's going to flash up keypad lock in the display. Now, anytime anyone comes in and they unlock or they do the finger swipe, and they press a button, they want to get into the parameters, it's going to say keypad locked.
Okay, so if it's locked and I come up to it, how do I unlock it?
All right, so now we got to unlock it, right? So if we want to get in and change something, we got to unlock it. So to unlock it, you're going to press any button for 5 seconds. It doesn't matter which one, just press it for 5 seconds. Again, your passcode screen is going to come up. Again, working from left to right, now you've got to enter the passcode. Once that last digit's in, you press the menu button. Then it's going to, if you've put it in correctly, it's going to flash unlock keypad or keypad unlocked at this point. Now you can make your adjustments. Key thing is, if somebody does this, make sure you write that number down, right?
Absolutely.
Make sure you write that number down. So keep that in mind. All right. Most people typically don't, but it is there. So your service menu, again, like I said, the service menu is basically just going to show us what's going on with the heater, right? So I'm going to press that pull SPA button for 5 seconds. Doesn't require a passcode. It's going to pull up the service menus. You're just going to use that up and down arrow to scroll through the menus. And once you get done looking at everything, press the pull SPA button again to exit it. Pretty simple. It's not hard. First thing you're going to see is delta T. We talked about this earlier.
Mm-hmm.
Now, manual says 10 to 14 degrees. And again, as long as you're kind of within that range, you're probably going to be all right.
That's ballpark.
That's ballpark. Yep. If you see something, you know, like I said, you see 1, that's probably a red flag for something. More likely you're going to have other issues. Same thing if you saw a really high number. You're probably going to have other issues such as a high limit trip or something of that nature. So again, just keep that in mind. Flame signal, unfortunately, again, like I said, it doesn't give you a number. It just says yes or no. Well, guess what? If it's running, you know you got a flame signal. So that's kind of redundant. It doesn't make a whole lot of sense, but it's there. You can also see your inlet and your outlet water temperatures. So you can see those individually as well. Cycles, you see the number of successful ignition attempts, how many times it's actually lit off correctly and properly. And then lockout screens. The control will log the 10 most current faults by the I won't say date time because there's no date time.
It basically it kicks the oldest one out when you get a new one coming in is basically what happens.
Yeah, so screens 4 through 8, there's going to be 2 lockouts per screen, so that kind of gives you the list there that you're looking for. So, all right. So again, starting with the newest, going to the oldest.
Yeah, and one thing I do like to throw out there with the lockout screens, it is handy to have that, especially if you get a call, you know, from a homeowner saying, "Hey, don't have heat, blah blah blah," and you get there and they've reset it, you can actually go in to see what it's locked out on. So if you go in, you see, hey, air pressure switch, and it's been 1.5 years since it's been serviced, you now know the right route to go. So that's where it helps me out, because the hardest unit to troubleshoot is one that's running, and we all know that. So that's something that I always look at when I run into that situation.
Yeah, so that's a good thing to look at, is what those faults are. Like Jonathan said, if it's an air pressure switch fault, then hey, you know where to go to, how to set those air pressures, the deck pressure and the differential, what we're looking for. You see a flame failure, which is probably your most common. That means it didn't improve the burner flame. All right, so why didn't it improve the burner flame? You know, is it a gas air mixture issue? Is it a venting issue? You know, is it a possible flame rod issue? Right?
Yeah, could be.
So, so now we can use that information to basically start narrowing down our troubleshooting a little bit. All right, so basically we are at the end of the presentation. We're just a few minutes over past 10 o'clock.